Hello, I am Harshvardhan Singh and I am going to give a presentation on the problem statement which has been assigned to me, and that problem statement is all about thermal comfort and how radiation effect has to play a major role in this thermal comfort. So I have given the title as radiation effect on thermal comfort. Now we begin. So these are the contents. First we'll go to the thermal comfort part. We'll understand that what thermal comfort actually is. Then we'll go to the objective of the heat transfer analysis to understand that what is the main motive which actually drives us to do this analysis. Then we'll go to the problem statement. Then we'll go to the schematic. In schematic we'll actually understand this problem statement in a much brief and schematic way, like what it has to say. And then we'll go to the assumptions. We'll understand that what are the assumptions that have been kept in mind while solving this problem. Then we'll go to the analysis, and this analysis part is actually the core part. Then we'll go to comment section. Let me choose the laser pointer now. Okay. So now we'll go to the next slide, and the next slide is on thermal comfort. Okay, so what is this thermal comfort? Thermal comfort is actually that condition of mind which expresses satisfaction with the thermal environment, and this is actually a definition which has been provided by ASHRAE, American Society of Heating, Refrigerating and Air Conditioning Engineers. It has been provided by them. Thermal comfort, it actually dates back to the beginning of human history. Like in old days, it is believed that early human beings lived in caves that provided shelter as well as protection from extreme thermal conditions. So we can understand that thermal comfort, this term is something this is not a new term. It has been present in the mind of people since ages. People were much concerned about it. And then we'll go to the parameters which actually affect the thermal comfort, and the three environmental factors that actually affect thermal comfort are temperature, relative humidity and air motion. And on all these three parameters they are somehow associated with heat transfer. So we can say that overall it has something to do with the heat transfer. It affects the heat transfer. Okay, so now we'll go to the next slide, that is the objective of the heat transfer analysis. We are doing this heat transfer analysis to provide a convincing explanation with proper calculations that why a person feels comfortable in summer but chilled in winter when the room temperature and the natural convective heat transfer coefficient is kept same. We have to give an explanation for this, and we'll come to this explanation. We'll get this point by the end of our analysis part after doing some necessary calculations. Okay, so now we'll go to the next slide, that is the problem statement. As we can see that this problem statement is quite big, so we will try to understand this problem statement in a much short and concise way by having a look at the schematic. We'll go to the next slide now, and here is the schematic. So there is a person sitting in a room and his body surface temperature is mentioned in the problem, that is 32 degrees Celsius. Then body surface emissivity is also given, the room air temperature is also given, and the convective heat transfer coefficient associated is also given, and the wall temperature is also given. And one point has to be noted over here, that this data and this data is not changing with season. It remains constant with change in season, but this data, that is the wall surface temperature, is actually changing with season. That is, it is different in summer and different in winter. In summer it is 27 degrees Celsius, in winter it is 14 degrees Celsius. Okay, so now we'll go to the next slide, that is assumptions. Okay, so the first assumption we have taken is that steady state condition, which means that the temperature, that the surface temperature or the room air temperature or in temperature, the temperature in this particular problem is not changing with time. It remains constant with time. Okay, so this was all about the first assumption. Then the second assumption is that the radiation exchange between the body of a person and the room is between a small surface and a much larger enclosure. And the third assumption is that the surface emissivity and absorptivity are equal. And we have come to this assumption by understanding the Kirchhoff's law. The Kirchhoff's law states that emissivity is equal to absorptivity for a gray body. So indirectly, we are also assuming that in this problem, the body is a gray body. Okay, now we will go to the next slide. And this is the analysis part, that is the core part of this presentation. And over here we'll discuss that thermal comfort is something which is somehow linked with the heat loss from human body. When this heat loss is excessive, we feel chilled, whereas we feel comfortable when it is moderate. In the given problem, the room air temperature and the body temperature is fixed, but the wall temperature is varying with season, and I have already discussed about it earlier in the schematic diagram. And the natural convective heat transfer coefficient associated is also fixed. So it is quite obvious from our general intuition that the convective heat flux also has to remain constant in summer and winter. And we can see this H remains constant. This Ts is the body surface temperature of that person in the room, sitting in the room, and this T infinity is the free stream fluid temperature, and over here the free stream fluid is the air. So this air temperature is also constant with season. It does not change with season. So obviously if entire thing remains unchanged, so this value will also remain unchanged. Okay, so that's all about convective heat flux. Now we will find the radiative heat flux, and first of all we have to understand that in radiation we have two components. In radiation we have the emission. We find out the emission which is taking place from a body, and then we subtract the amount of irradiation absorbed from that body. And in this formula we can see this part is actually for the irradiation part, and here actually there should be alpha, but since we have assumed that this is a gray body and absorptivity is equal to emissivity, so that absorptivity is equal to emissivity, so alpha becomes epsilon over here, and that epsilon has been taken out as considering it as common, because epsilon will also be present over here and here, so it has been taken out. So these two terms are taken out. And on solving this, this T sir is actually the surrounding temperature, that is the wall temperature. In summer, this temperature is more, so we can see this is in Kelvin. This temp. One more important thing is to be noted over here, that this temperature has to be in Kelvin, otherwise the answer will be wrong. But in the case of convective heat flux, we can keep it in degree Celsius or in any other unit. It does not matter. But here we have to keep it, not in any other, like over here we have to keep it in Kelvin. Here degree Celsius or Kelvin both will do, but here only Kelvin will do. Okay, so in winter also we do the same thing, and since the wall temperature is less, so definitely the difference will be more, the greater over here. So we understand that the radiative heat flux is more in winter. Why it is more, we have understood by looking, we have understood this by having a look at this formula. Now, since this radiative heat flux is more, so this means that the amount of heat loss will be more in winter. So that is why we feel chilled in winter. So as we can observe, there is a significant difference between the radiative heat flux in summer and winter. Thus, we can say that the chilled effect in winter is due to the excessive heat loss via radiation. Okay, now we go to the next slide, that is the comments section. Okay, so the first comment which we have done is that we conclude that radiation plays a pretty significant role in human comfort, and how it plays, we have proved it in our analysis. And I have also written, I have repeated this point over here because this is quite important, that one thing is to be made sure that the temperature may be expressed in units of degree Celsius or Kelvin when evaluating the temperature difference for convection or conduction heat transfer rate. However, the temperature must be expressed in kelvins while evaluating a radiation heat transfer. Okay, so we have completed this presentation, and thank you. Thank you so much for listening. Thank you.